So today we're going to start chapter 11, section 4, and we're going to learn about three-dimensional figures. So the first thing is a definition, and the definition or the vocab word is polyhedron. And a polyhedron is a solid bounded by polygons called faces. Also part of the polyhedron are edges, and the edges are the segment that is formed by the intersection of two faces. Then we have a vertex. The vertex is the intersection point of three or more edges. In plural form, you can call it polyhedra or polyhedrons. The picture here at the bottom, this is actually a picture of a trapezoidal prism. Now, notice the faces. The faces are all of the polygon sides here. The edges are the location of the intersection of two faces. And the vertices are where it's the intersection point of three or more edges. So the classic example I always like to show to my class is the tissue box. So it's a good way to demonstrate the faces, edges, and vertices. So I'm going to go up there and grab the tissue box and show you guys. These are different types of solids. Over on the left side in blue, those are examples of polyhedra. The two examples we're going to talk about are going to be prisms and pyramids. We're going to see coming up in the slides that to name a prism, whatever shape is on the base, that's the type of prism you have. The non-polyhedra, those are the cylinders, the cones, and the spheres. Notice their sides are not made up of polygons. They're curved. So when you have a curved side, it's not a polyhedron. So as soon as you see a curve to your solid, it's not a polyhedron. Next, we're going to talk about prisms, and I just showed you an example of one. So to name a prism, you're going to use the shape that is at the base of your prism. Now, you need to be careful because sometimes when they give you pictures of prisms in your textbook or on a test or a quiz or even in the homework, they don't always sit the prism on its base. Sometimes they turn the picture of the prism on its side. To figure out the name of the prism, you're looking for the shape that you have two of. So in this blue figure here, notice how I have two pentagons, and then I have the five parallelograms or rectangles that are around the sides. So whatever you have two of, that is going to be the name of your prism. The other faces that are not the bases are called the lateral faces. And again, those are going to be parallelograms that are formed by connecting the corresponding vertices of the bases. So in this case, these are a bunch of rectangles. The altitude or the height of the prism, you're going to be looking for a right angle because it's always going to be the perpendicular distance between the two bases. The bases are always going to be congruent polygons, and in this case, these are two congruent pentagons. Next is a pyramid. And again, we're going to name the pyramid by the shape that is at the bottom or the base of our pyramid. So a pyramid is a polygon with n number of sides and n number of lateral faces that all meet up at the vertex. So at the top, or that point of that pyramid, is where the vertex is located. The altitude is going to go, or the height of our pyramid goes from the vertex down to the base. So it would stop right here in the middle. And usually you're going to see a little right angle mark indicating that that is the height. The lateral edges are these edges on the outside here, going down. These are all lateral edges, outlining those lateral faces. So again, to name the pyramid, you're going to name it by the shape at the base. So in this particular picture, I can't tell if all of these sides down here are congruent. So I would name this pyramid, this would be a rectangular pyramid. If I had congruency marks on the sides, I could also call it a square pyramid. Now, the next slide, and we're going to be naming or counting. So the math involved here is going to be counting how many edges your solid has, how many vertices, and how many faces. Now, in our textbook last year, it included this theorem. It's called Euler's theorem. Now, I'm not going to test you on Euler's theorem. I just wanted to show you that this is a way that you can double check your counts to see if you've gotten them correct. So Euler's theorem just states that the number of faces plus the number of vertices should equal your edges plus 2. So again, if you want to just use this to double check that you counted the number of faces correctly, vertices and edges, you can double check it by adding faces plus vertices should equal edges plus 2. So in my picture here, it's a picture of a cube. And in my cube, I have 6 faces. So each one of these squares, all around the sides, and the top and the bottom, there are 6 of them. Those are the faces of my cube. Then the vertices are where the 3 edges meet. So these are all these little corners. 1, 2, 3, 4, 5, 6, 7, 8 of them. And then the edges, these are all the segments that connect these faces. And there are 12 of them. 4 around the top, 4 around the sides, and 4 around the bottom edges. So a total of 12. So again, if you add faces plus vertices, which is 6 plus 8, I get 14. And then if you take the edges and add 2 to it, these two numbers should be the same. And they are, so I counted correctly. The next thing we're going to do is decide, is the picture of the solid a polyhedron? If it is, we're going to name it. And then we're going to tell how many faces it has, how many edges, and vertices. So for the first one, number 1, notice all of the faces here are polygons, which makes number 1, or part A here, example 1A, this is, yes, it is a polyhedron. And the name of this, notice the congruency marks on that base, all sides are equal, making this a square pyramid. And now we need to count the faces, vertices, and edges. So faces, I have 4 triangle faces, those are lateral faces, and 1 square face, which is the base, giving me a total of 5 faces. I've got vertices, I've got the tippy top one here, and then I've got the 4 down here around the sides of the square, giving me a total of 5 vertices. And then now my edges, I have an edge here, 1, 2, 3, 4, and then around the bottom, 5, 6, 7, 8. A total of 8 edges. And now if you wanted to double check your counts, remember faces plus vertices should equal edges plus 2. And it does. So I did count correctly. The next one, notice this one has a curved side here, or curved edge, making this not a polyhedron. And once it's not a polyhedron, we're not going to name it. We're not going to count edges, vertices, and faces. We're done. Now, example 1C, this is the tricky one. Notice this is a prism. And the way that we will name it is by the shape that we have two of. Notice I've got a triangle here and a triangle here. The other three faces are rectangles. So again, the shape that you have two of, even though it's not sitting on its base, is the name here. And this is actually a triangular prism. Now that we've named it, it is a polyhedron because all sides are polygons. And now let's go ahead and count faces first. So we already said 2 triangle faces, 3 rectangle faces for a total of 5. The vertices, let's count them. We've got 1, 2, 3, 4, 5, 6 vertices. And now edges, my edges are here. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 edges. So now faces plus vertices equal edges plus 2. 11 equals 11. I counted my faces, vertices, and edges correctly. Now, notice on these figures, you see how it has these dotted lines? This is just indicating the part of the picture that's behind it that you're not supposed to see, because technically the solid isn't see-through. So whenever it's dotted, it's just like the back side of the solid. All right, let's try cross-section now. So a cross-section is the intersection of a plane slicing through the solid. So think if you took your solid and you chopped it off, like you chopped off the top of this pyramid, the shape that you would see when you pull it apart is the shape is the cross-section. Now, in all of the slides, the cross-section shape is going to be in purple. So here, where the plane is slicing this triangular pyramid, you can see that the slice, if you were to pull that top piece off and then look at it, it would be a triangle. So again, this is a triangular. So if you had to name this, notice the base shape here is a triangle. So this is a triangular pyramid. And the cross section where they're actually slicing this one is a triangle. Now, depending on where you make the slice, the shape of the polygon that results from that cross section is different. So, and we're going to see that on the next slide when we see the cube and all the different ways that they slice up this cube. So the first 4 pictures here, A, B, C, and D, it's originally a cube. And then they're going to slice through it with a plane. So when you slice and make a cross section for A, notice the shape that would result is a square. So the original shape is a cube. So for A, B, C, and D, the original shape is a cube. But for A's cross section, this one's a square. For B, when you make the slice diagonally, notice that purple shape is in the shape of a rectangle. So this cross section is a rectangle. And over here, again, when we're doing it diagonally on C, but not from like edge to edge, this shape, and again, if you just outline it here, is actually a trapezoid. So this would be a trapezoid cross section. And then here, if you just chop off the corner, what results here is a triangle. And the last one, they changed the solid on example E. This solid is called a cone. And when you slice it with that plane, the cross-section shape is a circle. So again, when it's in color, when you're doing the homework tonight, all the cross-section portions are in a different color, and in this case, they're all purple. The original shape was blue, the plane is in red, and then blue and red make purple, so the cross-section color is purple. So that is it. It's a lot of vocab. The only calculations or math you're doing here is counting faces, edges, and vertices. So that is it for 11.4.